This lesson is over quadratic word problems in one variable. Our objective for today is that I can write a one variable quadratic equation and use it to solve a real-world problem. Please make sure that you are reading the daily announcement, checking your Canvas messages, and completing the work session, especially as we get down to the end of our unit, which is rapidly approaching. So let's start. You may use the note-taking guide that's provided for you if you want, or you can just follow along on your own. Today, I just wanted to review the quadratic keywords that you might see in some of these questions for today that might help you zone in on what you're actually supposed to be looking for. Remember that when we do these word problems, they're really not anything you haven't done before. They're just putting a little bit of context to it, which makes it a little bit more difficult, but manageable. So if a question is asking you for solving for length and width, which you're going to see a few times today in your work session, when it says to solve for length and the width, you're basically just solving for x. And when you are solving for x, that's the same thing as solving for your x-intercepts or your roots or your zeros or your solutions. So there's a lot of different things we could do when we're solving for length and width. We could factor, we could use the quadratic formula, we could complete the square, we could really do any of those to help us. Some people mostly find factoring is most efficient, but sometimes completing the square is, sometimes graphing is, sometimes factoring just is, whatever the option is. Some other quadratic keywords we could look for is when word problems say items like highest point or time in the air. So those are specific characteristics to a parabola, like the vertex or the zeros, or sometimes even the y-intercept if it talks about initial height. So just a reminder that think about what the question is asking for and how that would match up to whatever quadratic characteristic you're thinking of. Let's start with our first example. We're going to do one of two examples here. If you have a highlighter and you're using the note-taking guide, it might not be a bad idea, or you could just use your pencil to underline it. It says, given that the length of a rectangle is 5 units more than the width, the area of the rectangle in square units can be represented as A equals x times x plus 5, where x is the width and x plus 5 is the length. If the area of the rectangle is equal to 24 square feet, what is the length and the width of the rectangle? So let's pull out some important information there because we kind of had a lot. It says that the length of a rectangle is 5 more units than the width. It also gives us an equation for the area, which is helpful. In some of your work session problems, you'll actually have to build that. It says that x is the width and x plus 5 is the length. And then it's asking for what is the area if it's equal to, if the area is equal to 24 square feet, what is the length and the width of the rectangle? That's what we're looking for. Many of you, just in reading that problem, probably pictured a rectangle right off the bat of x and x plus 5 with an area equal to 24. In this case, I almost just wrote an x again. There we go, 24 square feet. So let's just define those variables off to the side again so we're making sure. X is going to be equal to the width of this rectangle, and x plus 5 is going to be equal to the length. Let's write an equation to represent that. We already know that the area is x times x plus 5 from what they gave us, but see how that matches up to x equals the width times the length, which is the formula to figure out the area of a rectangle. Let's fill in our area now. We know that our area is 24 square feet, so we now have this as our equation. Let me rewrite that. There we go. X times x plus 5. On the right side, let's do the distributive property. So we're going to have x squared plus 5x. And if we were trying to find that length and the width, this kind of goes back to the quadratic keywords. We're looking, if we're finding length and the width, we're looking to get our zeros or our solutions, our roots, x-intercepts. We're basically going to be solving for x. So to do so, let's get that 24 to the other side of the equation by subtracting it. And remember that we can't subtract 24 from either term because they aren't alike. So we're just going to have that negative 24 at the end. I'm going to choose to solve this by factoring. So I'm looking for numbers that multiply to make negative 24 and add together to make 5. You can pause the video if you want to think of those two numbers, or you can join me in seeing that it must be 8 times negative 3. Now, since our a value is 1, we can just write our equation in factored form right away. it would be, all these things are going to go off. There you go. X plus 8 and x minus 3 is equal to 0. And since we're trying to find the solutions, let's set each binomial equal to 0. So here we would subtract 8 on both sides. We'd get x equals negative 8. And here we'd add 3 on both sides, and we get x equals 3. Now let's think about this sensibly. Can you have a length or a width that's negative 8 units? No, you can't. Can you have a length or a width that's 3 units? Absolutely, that's a positive number. So if we go back to our problem, if x equals 3, 3 is our width. And if x plus 5 is equal to 3 plus 5, which gives us 8, that must be our length. And we can check really quick to make sure we're correct. We can do 3 times 8, and that should give us 24, and sure enough, it does. Let's try one more question. These ones look shorter, but they do give us a lot of information, and we'll kind of discover that as we read through this problem. So our second example says find 2 negative consecutive even integers whose product is 120. So in that, we have a lot of different pieces of information. We have 2 negative consecutive even integers whose product is 120. Reminder that product implies multiplication. So we did do questions like this in Unit 2, but in that case, we were adding them since it was our linear unit, and now we're multiplying them. But the process is still the same. So 2 negative consecutive even integers. If we have 2 consecutive integers, that implies that they're 2 numbers next to each other, like, and in this case, even, like 10 and 12 or 8 and 10. So let's define x first. We're just going to say x is an even integer, whatever it is. And if we want to find the next even integer, we can't just add 1 to it. We would have to add 2 to it because even integers are 2 units away from one another. So here we'd have x plus 2. That's our next even integer. And we know that the product of these, so x times x plus 2, is going to be equal to 120. Now you might be wondering why we haven't dealt with the negative part of this yet, but we'll get to that as we get our 2 zeros. So here, let's use the distributive property. We're going to have x squared plus 2x equals 120. And in this case, there's really 2 ways to solve this. I'm going to choose factoring for one way, if you want to choose factoring, or we're going to complete the square in the other way. And you can choose whichever way you would like to. I wasn't put complete the square. You can use whichever way you like. I just want to show you both of them, and then you can pick between the two. If we're going to use factoring, then we need to get that 120 over to the other side. So we would have x squared plus 2x minus 120 equals 0. We're looking for numbers that multiply to make negative 120 and add together to make 2. So those two numbers would be 12 and negative 10. Since a equals 1, I can just rewrite this as x plus 12 times x minus 10 equals 0. Here I end up with x plus 12 equals 0 and x minus 10 equals 0. I'm going to subtract 12 on both sides. I get x equals negative 12. And x equals, if I add 10 on both sides, x equals positive 10. So we've got our 2 possible answers. But the problem is that we're looking for 2 negative integers that multiply together to make 120. 10, positive 10 isn't negative, so that's not going to be our answer. Negative 12 is going to be our answer. So if x equals negative 12, and we're x plus 2 is our next number, negative 12 plus 2 gives us negative 10. So let's do the same process, but by completing the square. And again, you can choose which way you find easiest. So we're at this point here. X squared plus 2x equals 120. So if I complete the square on this side of the equation, I would have x squared, my 2 x's, and how many unit tiles do I need to complete the square? 1. Perfect. So I've got x squared plus 2x plus 1 is equal to 120 plus 1. If I complete the square on this side, I have x plus 1 squared equals 121. Take the square root of both sides, and I'll end up with my 2 equations. Here I'll have x plus 1 equals, the square root of 121 is 11. Over here I've got x plus 1 equals negative 11. Subtracting 1 on both sides, I get x equals 10. And subtracting 1 on both sides here, I get x equals negative 12. So if you notice, I got exactly the same answers as I did when I was factoring. You can choose which way you want to do this. It doesn't matter to me at all. So in this case, again, we can't have a positive number, so we know that one's not right, since our problem is talking about negative integers. So I'm going to select this x equals negative 12, and I get the same answer as I did with factoring. If x equals negative 12, then x plus 2 would be negative 12 plus 2, which gives us negative 10. So our two integers, whose product is 120, that are negative and consecutive and even, are negative 12 and negative 10. And just to check to make sure we're right, we can do negative 12 times negative 10, and we get 120, which is what we wanted. So kind of a tricky problem, but remember, defining what you are looking for is really the most difficult part. So think about what words are kind of key in the problem to help you figure that part out. And if you need help with that, you can jump on Microsoft Teams. So for the rest of today, you've got 5 problems to do for your work session. Make sure you show your work so I can give you some good feedback and comments on that today and tomorrow. Remember, you've got this, and if you feel like you need some help or you're struggling, just email me, send me a Canvas message or a Microsoft Team meeting, which is linked right in the assignment. You can jump on there for some help.